Hi everyone. So today we'll be looking at non-annual compounding in financial management. So what is non-annual compounding? Usually the time period in present value and future value questions is one, that is payments are made at the end of 1 year, which makes calculations pretty easy. For instance, suppose you currently have a $2,000 and you plan to purchase a 3-year certificate of deposit that pays 4% interest compounded annually. So how much will you have when the CD matures? That is what will be the future value. The computing here is calculation here is pretty easy. Since the compounding is annually, that is the CD pays after 1 year, so you plug in the following values in the financial calculator and find the future value. N is equals to 3 since it's a 3-year certificate of deposit. Present value is $2,000. The interest rate is the nominal interest rate of 4%, and you plug in these values and you'll find the future value. But in non-annual compounding, interest payments could be made semi-annually, quarterly, monthly, or daily. That is, the compounding is more frequent than annual compounding. This is the basic difference between non-annual compounding and annual compounding. So in non-annual compounding, 2 changes are required. That is, you have to adjust your N, that is number of periods, and your interest rate. Now we'll take the previous example, but we'll compound it semi-annually. So we have present value as 2,000. It's a 3-year certificate of deposit. Nominal interest rate is 4%, but it is compounded semi-annually. So in this case, what will be the future value? Here we have to adjust N and I, like I just said. So for N, you will multiply 3, that is the number of years for which your financial instrument is, by the compounding period. Since it is semi-annually, we will multiply N by 2, that is 3 by 2, and we get 6. And for the interest rate, we have to divide the nominal interest rate here, which is 4%, by 2, that is the number of compounding periods, and we will get 2%. The present value is the same. We will plug in these values in the financial calculator and we'll be able to find the future value. Now similarly, if we were to compound the same question quarterly, that is, the present value will remain the same, the certificate of deposit will remain for 3 years, the nominal interest rate is 4%, but it is compounded quarterly. So the adjusted N will be, we will multiply 3, the certificate of deposit of 3 year, by 4, since there are 4 quarters in a year. And for the interest rate, we will divide the nominal interest rate, which is 4%, by the number of compounding period, which is 4. The present value is the same. Plug in all these values in the financial calculator and you'll find the future value. Now using the same question but compounding it monthly, here for the adjusted N, we will multiply the 3-year certificate of deposit by 12, since there are 12 months in a year, and we will have N as 36. For the interest rate, we will divide the nominal interest rate 4% by 12, and this is our adjusted interest rate. The present value is the same. Plug in these values in the financial calculator and you'll find the future value. Now if you were to compound the same question daily, the adjusted N here is 3 times 365, since there are 365 days in a year. For the interest rate, we will divide the nominal interest rate in the question, 4%, by the number of compounding period, that is 365. The present value is the same and we'll be able to find our future value. Now let's dive into some questions to understand the concept in detail. So these questions are the ones that I took from Eugene Brigham. And so in this question, we have the same present value. For part C, we will compound quarterly. So for N, we will multiply number of years 5 by 4, since there are 4 quarters in a year. For the interest rate, we will divide 12% the nominal interest rate by 4. That is the number of compounding periods. Plug in all these values in the financial calculator and this is what we will get. For part D, we have to compound monthly. So we have to adjust N and I. For N, we will multiply 5, the number of years, by 12, since there are 12 months in a year. For interest rate, we will divide nominal interest rate 12% by number of compounding period, which is 12. Plug these values in the financial calculator and this is the future value that you will get. In part E, we have to compound daily for 5 years. So for N, we have to multiply number of years 5 by 365, since there are 365 days in a year. Divide the nominal interest rate 12% by 365 to get the adjusted I. In part F, it says, why does the observed pattern of FVs occur? So what is the pattern that is occurring? In part A, we were compounding annually, so we had 881, but since as the compounding periods increase, that is from annual to semi-annual to quarterly, and then to monthly, and then to daily, you will see that the future value increases gradually. So from it increased from 881 to 909. So the answer is that the future value increases as the compounding period increases, because the interest rate is applied on the increased amount each time. So as compounding periods increase, the future value increases. Let's look at another question. So in this question, in part A, it says that you plan to make 5 deposits of $1,000 each, one every 6 months, with the first payment being made in 6 months. You will then make no more deposits. If the bank pays 6% nominal interest, compounded semi-annually, how much will be in your account after 3 years? So for part A, it's semi-annual compounding, since the question mentions it, and the timeline of deposits that you're making is as follows. So I've observed that when you make a timeline of your deposits, the question becomes much more easier. So we'll divide our time period into 6 months. The first 6 months, and then another 6 months, and then another 6 months. And these are the deposits that we're making. That is, so this is an annuity, since we're making equal deposits. Since the deposits that we are making are for 2.5 years, but we want to find out the value in our account after 3 years, this is what we will do. We will first find out the value in our account after 2.5 years. So we'll adjust our N and I accordingly. Here, N will equal to 2.5 times 2, since this is semi-annual compounding. The interest rate, the nominal interest rate here is 6%. We will divide it by 2, which will come out to be 3%. PMT, that is the equal payments, are $1,000. The present value is 0, since we don't make a deposit at year 0. And we'll find the future value by plugging all these values in the financial calculator. So the future value after 2.5 year turns out to be 5309.14. Now remember that this future value is for 2.5 years, but in the question it says that we have to find our future value after 3 years. So we need to find the future value for another period, and that period that is for another 6 months. So the new information will be N is equals to 1 period, I is equals to 3%, which we just found above. PMT is 0, since the question says that we don't make any payment in the last 6 months. And the present value is the future value that we found in after 2.5 years. Plug in all these values in the financial calculator, and you'll be able to find the future value, which turns out to be $5468.41. Now I understand that using the financial calculator for this part, for these 6 months, is a bit difficult to understand. So we'll also solve this question using the formula, the future value formula. So now let's look at the time period once again. This is the time period. We make our deposit after 6 months, another one after 1 year, another one after 1.5 years, another one after 2 years, another one after 2.5 years. But after 2.5 years, we don't make any deposit, right? So the present value after 2.5 years was 5309.14. To find the future value after 3 years, this is what we'll do. We'll plug in the present value that we found, and we'll multiply it by the 1 plus 0.03, which is the interest rate that we found earlier. So in part B, the question says that 1 year from today, you must make a payment of $4,000. To prepare for this payment, you plan to make 2 equal quarterly deposits at the end of quarters 1 and 2 in a bank that pays 6% nominal interest compounded quarterly. How much large each of the 2 payments must be? So we have to find PMT for quarters 1 and 2, which are equal. Here the time period is as follows. Since we have to make quarterly payments, there are 4 quarters. So the first payment will be made after 3 months, another payment will be made after 6 months, another payment will be made after 9 months, and then the final payment will be made at the end of year 1. And these are the schedule of deposits or payments. So at period 0, $0 are deposited after 3 months. X dollars are deposited and after 6 months another X dollars are deposited, and we don't know what the payments are made in the third and the fourth quarters are. Since we need to find the future value at the end of quarter 2 and not quarter 4, we need to find the new future value, which is actually present value for quarter 2. So the future value given here is $4,000, but we need to find a new future value, which will be the present value for quarter 2. So we will discount the values back 2 quarters. Here we will find the adjusted N and I. For N, we will multiply 1 by 2. Since the year here is 1, that is 1 year from today we have to make our payment, and there are 2 quarters for which we need to find the present value. We will multiply 1 by 2, and we'll get 2, and for the interest rate we will divide 6%, the nominal interest rate, by the number of quarters, and there are 4 quarters, so the interest rate turns out to be 1.5%. The future value here is $4,000, the PMT is 0, and we'll find the present value. The present value turns out to be $3,882.65. So now we apply the PMT formula on this new value. The future value is 3,882.65, N is 2 as before, the interest rate is 1.5%, the present value is 0, and we find the PMT, which turns out to be $1,926.